Okay, this video is about finding missing angles using trigonometry. Previously, we've learned about finding missing sides, but now we're going to find missing angles using trigonometry and sine, cosine, tangent, and all that stuff. So we're going to find this missing indicated angle question mark for both of these triangles, and we're going to round it to the nearest hundredth of a degree. So that's 2 decimal places. Okay. So now this angle right here is the question mark angle that we're trying to find. I'm just going to call this x, because x is some unknown value. Okay. We'll talk later about what we call it traditionally in geometry called theta, but x is our unknown for right now. Now I'm going to label all of the sides according to that angle as opposite. The hypotenuse is this unmarked side, and the adjacent side is 33. So when we look at this, we can see that the 33 and the 15 are the adjacent, the opposite sides. So we know that we have the 33, which is, I'm just going to say A for the adjacent side, and 15, which is O for the opposite side. So knowing that we have the adjacent and the opposite side, I'm going to write SOHCAHTOA, and we're going to determine which one of the trig ratios, the SO, the CA, or the TOA, are we going to use if we have an O and an A. Well, in this case, the TOA, the tangent, uses the O and the A, the opposite and the adjacent. So I'm going to set up a ratio, the tangent of this angle, well, the angle is x, so the tangent of x is equal to, the opposite comes first, the adjacent comes second. So opposite is 15, 15 all over 33. Now, we have to get x all by itself. So essentially, when we want to eliminate this tangent. Now in order to eliminate a tangent, we have to do what's called the inverse. So I'm going to make a little side note over here. To eliminate any trig operation, we are going to use what we call the inverse. Now what we're going to do essentially is we're going to take this left side and we're going to take the inverse. And the way you write the inverse of tangent is this tangent with a -1 as its exponent. What that does is eliminate the tangent, and then all you're left with is having an x. But you can't just do it to one side. We have to take the inverse tangent of the right side as well. So now x is the only thing left over on the left side, because the tangents eliminate, and this is equal to the inverse tangent of 15 divided by 33. Now I'm going to show you in a calculator how you would get the inverse tangent. Okay. So here's my scientific calculator with the sine, cosine, tangent functions. You'll notice right above the tangent button is this tangent with the -1. So there's the inverse tangent. Because it's in blue, you're going to have to hit the second button, or possibly a shift on your calculator, and tangent. Then you see the parentheses start, and then we're going to input the fraction 15 divided by 33. So 15 divided by 33, close the parenthesis, and this should get you a value of 24.44. Now rounded to the nearest hundredth, it's just 44.44. We're not going to leave the 3. The 3 will keep the 4 a 4. So x rounded to the nearest hundredth is 24.44 degrees, because x is a degree measure in this case. Now if you don't get 24.44 and you're confused why, and you're doing everything right in your calculator, it's because your calculator may not be in degree mode. Okay? So if you have a calculator like this, change the degree mode to degrees. You can see that there's a degree button right here, and you want to stay in degrees. You might be in radians or something other than that, but you want to be in degree mode. Otherwise, if you have another calculator, just go to the mode and change the mode to degrees from radians. So that's example 1. Let's jump down to example 2. We want to find this question mark. In this case, I'm going to leave it question mark. You really can call it x, you can call it whatever you want. This is just the unknown value. And I'm going to label all the sides, opposite, hypotenuse, and adjacent, okay, according to this angle. Now we know that the two sides we have, 29 and 43, so we have the sides 29, which is equal to the adjacent side, A, and 43, which is equal to the hypotenuse side, H. That takes us to the SOHCAHTOA and we have to determine which one of these trig ratios uses an h and an a. So if you look at that, the ka in SOHCAHTOA, the cosine uses a and h. So we're going to set up the equation, the cosine. In this case, the angle, and I left it question mark, is just question mark, is equal to the fraction. A comes first, h comes second. So a is on top, the 29 is the adjacent side, divided by 43. And then to eliminate the cosine, remember we have to take the inverse cosine of everything. That eliminates the cosine, but now we're going to have to take the inverse cosine of this fraction on the right. So now the question mark is equal to the inverse cosine of 29 over 43. I'm going to move back to my calculator, and I'm going to do the inverse cosine, hit second cosine with that -1 as the exponent, 29 divided by 43, and that is approximately equal to 47.590. Now if we're rounding to the hundredths, the 0 is going to keep the 9 a 9, so the question mark is equal to, or approximately when we round it, 47.59 degrees, and that's it. Now we're going to jump to the rest of the notes. Okay, using trigonometric ratios, we always have to have a right triangle. So you must use a right triangle with sine, cosine, and tangent. Okay, but if we do not have a right triangle, we can make a right triangle by using the triangle's altitude. Okay, so I'm going to do that right here, and then we'll read the next. The altitude of a triangle is the highest point, but we're going to make it perpendicular to the base, to the bottom side length, so that we now create a right triangle. So essentially we have a right triangle on the left and a right triangle on the right. So both of these are right angles, but where this previously had no right angles in it. Okay. Now we are trying to find this measure of this symbol right here. Well, that's an angle. Now this is where I'm going to talk about what we said kind of up there. We can name it anything. This is what we're traditionally going to use now. The theta, and this is the symbol theta, which is a Greek letter, and this Greek letter is commonly used in geometry to represent an angle. So theta is just a Greek letter, like we have the letter X. This is a Greek letter theta that they use for an unknown, and it's commonly used to represent an angle. So we're going to find this angle. Now, if I look at the right triangle that the angle is in, we only have one side length. But in order to find the angle, we had to have two side lengths. So we need to find one of these two other side lengths, and we need to calculate that. So we're going to calculate that using the information on this right triangle to the left. We have 44, we have 24. To find the side length that is shared between both of these, we're going to find this, and I'm going to call this x. So I'm going to break this triangle to the left off on its own, and I'm going to redraw it as just a right triangle with an angle 44 degrees, with a hypotenuse of 24, and the side length, the altitude of that, as x. And we're going to solve for x first. So there's going to be an intermediate step that we use to solve for x. Then using that side length, we can use the inverse over here to find theta. So I'm going to start labeling the opposite side. This is the opposite. We have the hypotenuse. The adjacent is unmarked, but we know that we need to use the opposite and the hypotenuse. So if we go back to SOHCAHTOA, if we have the opposite and the hypotenuse, we need to use the sine. So I'm going to set up a ratio. The sine of the angle that we know, 44, is equal to O over h. So O divided by h, the opposite is x, divided by 24. Now that's the trig ratio set up. We are going to now solve for x. So once we have a denominator of 24, we want to eliminate the denominator of 24 by multiplying by 24. So 24 times the sine of 44 is equal to, all that remains is x. And this is where you're going to have to go back to the calculator. 24 times the sine of 44 is approximately, let's round this, and it says, if I'm reading the instructions, round intermediate values to the nearest hundredth. Hundredth is 2 decimal places. So we're going to round this intermediate value before we find theta to 16.67. The 1 keeps that as 7. So this x value is 16.67, and that's the rounded value of x. Okay. So that's this value, and I am going to go over here and write this as 16.67. So we now know this height right there. I'm going to move over further to the right, and I'm going to move and draw the right triangle on the right side. Where we have theta is our missing angle, but now we know that this side length is 16.67, and the hypotenuse, which is 18. Now again, I'm going to label according to the theta, the angle that we are trying to find. This opposite side and the hypotenuse are the 2 sides length we have. The adjacent is again unmarked. And we know that when we use the opposite and the hypotenuse, just like the previous example, we're going to use the sine. So I'm going to set up a ratio. The sine of that angle theta is equal to the ratio of the opposite divided by the hypotenuse. So 16.67 divided by 18, which is the hypotenuse. And then we've talked about to eliminate any sine value, to get that kind of eliminated, we have to take the inverse sine of both sides. So I'm going to take the inverse sine. Now that's going to eliminate the sine, so all that we have left, theta, which is equal to the inverse sine of 16.67, all divided by 18. And I'm going to go to my calculator to solve for this value. The inverse sine of 16.67 divided by 18. And that's going to be approximately, rounded to the nearest, and I'm reading the instruction, round theta to the nearest tenth, which is just 1 decimal place, so 67.8. So theta is approximately 67.8 degrees. And so that is the angle measure of this triangle, where we previously didn't have a right angle. We created the altitude to make a right angle, and then solved some intermediate step in order to solve for theta. Okay, last step in the notes, step 4. We are going to find, or we're going to draw or sketch this triangle represented above. So triangle XYZ is a right triangle. Okay? The angle in that triangle Y is the right angle, and the side length XY is 9, but the side length XZ is 15. So part A, sketch the triangle below. We know that this is a right triangle because it says so, and that the angle Y is at the right angle, stated here. Now we have to label these X or Z. These are the other 2 points in the triangle XYZ. Now it doesn't matter. You can put the Z up top or the X down below, but I'm just writing it this direction. Now, if I'm labeling the side lengths, be sure to label all side lengths and angles. XY is 9, so between X and Y we have 9. XZ is 15, so between X and Z we have the length 15. Part B says calculate the missing length of YZ. So YZ is this missing length that we don't have. Now in order to do that, you can do trigonometry, find this angle or angle X or angle Z, then use trigonometry again to find this missing side length. But there is a more famous theorem, Pythagorean theorem, that helps us solve for right triangles and missing sides, assuming that we have 2 of the 3 sides. So if we use the Pythagorean theorem, know that C in the Pythagorean theorem is always the hypotenuse. I'm going to call this A, and B is the missing side. So in the Pythagorean theorem, A squared plus B squared equals C squared. A is 9. B is unknown. Let's just keep it as B squared rather than writing question mark. And C is 15. Continuing to work through the Pythagorean theorem, 9 squared is 81, plus B squared, and 15 squared is 225. So in solving for B, we have to get it isolated. So we are going to subtract the 81 and get b squared to equal 225 minus 81. Well, that is 4. 4 we borrowed a 1, and you get 1. So 144. Then take the square root of both b squared and 144, and so your b value is equal to 12, and the side length for x, or to yz, is 12. Now part C, find the angle measures of x and z. Anytime we want to find angle measures in a right triangle, we're going to use the inverse operation from the previous example 1 and 2. So I'm going to redraw this triangle. This is y, z, and x. And we know side lengths are 9, 15, and 12. Now, it doesn't matter which one you choose to solve for first. You can solve for x or z first. We're going to solve for x first, just because that's what I chose. Comes first in the alphabet. So when we solve for x or find the angle x, I'm going to use the opposite, the trig identities, and we're going to use one of these two. So I first label the opposite adjacent hypotenuse. Now, because you have all three sides, where previously we only had two, you can really use any trig ratio. I'm just going to choose sine, because that's the first in SOHCAHTOA. So the sine of that x angle that we're trying to find is equal to sine is opposite over hypotenuse, so O over H in SOHCAHTOA. O is 12, H is 15. So in order to solve for x, we're going to take the inverse sine of the fraction 12 over 15. Jumping back to my calculator, the inverse sine of 12 over 18 is equal to 41.81 degrees. Now this doesn't ask us to solve specifically or round specifically to a certain point, so let's just round it to 81. Okay. So x is an angle approximately equal to 41.81 degrees. So this angle up here is 41.81 degrees. Now, in order to find z, there's a couple different ways you can go about it. We can use another trig ratio according to z, and maybe this is the opposite in the hypotenuse again, so we use sine, the inverse sine of 9 over 15. But I know that in a right triangle, or any triangle for that matter, that all sides add up to 180. Okay. So I'm going to add these two up together, or subtract these two from 180, and take 180 minus the 90 degrees from the right angle, and then also subtract the 41.81 degrees from the angle x, and that should help us find angle z. So once we do this, if you subtract this, you should get 48.19 degrees. So the missing angle for z over here should be 48.19 degrees.